Hello, hello, hello.
Hello, hello, hello.
Hi.
Yeah, we are literally across the world.
Yes, crossing all three time zones.
Yep. So, Zach, how are you doing today?
I'm doing good. This is my
You're
second
from the
coffee.
future. So,
Yes,
yeah,
I'm this is my second coffee. It's early morning
awesome.
in my time, yeah. And how are you doing, Jones?
Doing good, doing good. Just wrapped up the day, and yes. So, today we have an amazing guest who's specialized with DynamoDB. So, Uriel, who's already on stage,
Yes.
welcome to the podcast. We're great to have you and share a little bit of your expertise with DynamoDB. So,
Yeah,
Uriel, do you want to introduce your own self?
yeah. Thank you, Jones. Thank you, Zach. Yeah, so I'm a AWS cloud consultant, specialized in DynamoDB. I do DynamoDB consulting and design, of course. I do also a little bit of work with serverless, mostly AWS. I've been in the field for about 12 years, almost a bit more than 12 years. And I've started my career as a freelancer. Then I went back into employee 9 to 5 jobs, and then recently I've actually come back to as a consultant, so on my own. So I've come full circle, and I really enjoy it. Yeah, enjoy working with AWS cloud. Very interesting and challenging work.
Awesome, awesome, awesome. Yeah, that's a great journey that you've had wearing multiple hats. I know you do write a lot of content as well. Do you want to talk about your blog?
Yeah, I've started my blog on I think it was in 2024. Was it January actually? So January 2024. It's been a bit over a year. I've been writing weekly on my blog on Medium. I write about everything from serverless to DynamoDB, cloud computing, and I also write on Substack. I have a few newsletters there on Substack and LinkedIn. I have my newsletter on LinkedIn, which I post every Friday or Saturday. So I have two newsletters. I have one newsletter on LinkedIn that's about DynamoDB, excelling with DynamoDB, best practice with DynamoDB, and another one on that has to do with cloud cost optimization. So I share weekly tips on how to reduce costs with the cloud. And so yeah, so those are my newsletters and my blog, which I post, I would say maybe a few times a week. Yeah, so Substack, Medium, LinkedIn, pretty much all over the place. I post on LinkedIn also every day. I post
Mhm.
on Threads, Twitter, and the new platform that I think it's called Blue Sky recently. Yeah,
Yeah, too many platforms these days.
Yes,
exactly.
everyone on Blue Sky.
Awesome. So let's talk about DynamoDB. Like, why would you choose DynamoDB?
It's a good question. So personally, I my journey with DynamoDB started when I about 6 years ago, I think, when I was looking for a scalable solution. I was building an app actually using, I think it was back in, I think it was Firebase I was using, and I had this problem where, well, not really a problem, but it was a future problem where my partner was telling me, this was for a startup, so my partner was telling me, um, this is very good what you're building here. We built an app for an MVP. Um, he asked me, is this going to scale? And I told him I have no idea. I made some research and I found that up to, I think, something like 100,000 users or something, maybe less daily active users, it can do
Mhm.
well, and beyond that it can become problematic. And when I told him that, he said that could be well, for sure for now it's fine, but it could be problematic for the future. So that led me down on the path to research for a more scalable solution, especially cost wise. And that's where I fell up on DynamoDB. And it was advertised as the perfect solution, the scalable and performance solution. And I tried it, I built with it, and that application never got to see the light of day, but I got something much more, I would say, valuable in return. I learned DynamoDB. I learned how to scale it. I learned how to make it, to design scalable and powerful and very efficient and low latency solutions for all kinds of clients that I have. And so that's really my kind of like first encounter with DynamoDB.
Awesome. Yeah, I hear that you were migrating from Firebase to DynamoDB. So you're still in the NoSQL world, but did you find that mindset shift when you're talking about SQL and migrating it to NoSQL? How was that journey?
Yes, well, actually, that application was with Firebase, but I started my career, I would say the first applications that I built like about 12, 13 years ago were with MySQL. So I did come from the SQL world, and I went from SQL to Firebase to MongoDB and to DynamoDB. So I kind of like went through the three different types, whereas SQL, it's a different mindset. Then there's the NoSQL that is not a key value store like the DynamoDB, for example, MongoDB and Firebase, and also a different mentality completely from DynamoDB. So all three of them, you have to really shift mindset. But even without talking about Firebase and MongoDB and all those NoSQL, if you're just talking about going from SQL to DynamoDB, there's a drastic, shift of mindset. You have to think really in terms of, denormalization. Are you working with, relational data? Are you building for scale? I mean, yes, there are ways to scale for sure. SQL, MySQL databases, but it's very hard. Come on, let's be honest. Scaling a database, an SQL database for hundreds and thousands of users is pretty darn hard. So DynamoDB makes it really simple, much easier, but you have to learn how to use it. And with that comes this big change in mindset where SQL, you have your best practices, you have to normalize, you have foreign keys, you have joins. In DynamoDB, you have none of that, so you really have to. And the issue is that DynamoDB feels like a relational database in terms where you have tables and you have primary keys, which doesn't exist in NoSQL. So is it NoSQL or is it SQL? Well, I really think of it as a hybrid. It's a hybrid between both, because you have primary keys which are schema enforced, but the rest of your attributes, other besides for your primary keys, don't have any schema, right? So it's like you have the NoSQL and the SQL at the same time, but even that, it's completely different. So you don't normalize in DynamoDB, you denormalize. There's no joins. You have to pre-join your data. You don't have filters. Which is something we're going to talk about also. You don't have a lot of the stuff you have in SQL, but you have a lot of everything. You have a lot of different things that you need to learn to make your database performant. And when you learn those things, those concepts in DynamoDB, you can build more performant databases than with MySQL or SQL.
Absolutely, Elvi. Yes. Yeah, coming from the SQL world, it is a huge shift, right? Before we get started and talk about the filtering part of it, you want to give any advice for somebody who's just learning about DynamoDB, just getting started with DynamoDB?
Yeah, so if I can give, even to myself a tip, on when I started using it, if I had known this, it would have completely changed. I would say is start before you build your DynamoDB database, before you do any of that, start with understanding your application's data access patterns. So it kind of has nothing to do with database design. Well, or you might think so, but it's more about, what are your users doing? How are they fetching data? How would you want them to query data? Like in what way? Those are access patterns. How are they getting data and writing data? Think of those, write them down. So there's nothing technical there. It's just, listing out in plain English, in your language, how you want your data to be accessed. Once you understand these, then you can start designing databases with DynamoDB. And the reason for this is because if you don't lay out your access patterns before, you can have a really hard time switching them, changing them, and implementing them like after the fact. So it's always better to have them before. And we'll get into details of this soon. Yeah.
Awesome. Yeah. Without more Easter eggs, probably. Yeah. Today we'll be talking about filtering and making more performant database queries, right? So yeah, over to you, Uriel, in terms of how do you come up with that whole access patterns? How do you design for certain access patterns? And yeah, want to learn more from you.
So, like I said, I start every time I build a DynamoDB database, I start by understanding my access patterns. Once I understand them, well, I'll write them down, and then I'll design my table, which is usually a single table. But we don't want to get into this rabbit hole of single table design, maybe for another episode. I'll design my single table with the access patterns in mind. The access patterns that I've listed out. So, for example, if I need to, if I have, like, we're going to use the example of a hotel application. If I think that one of the important critical access patterns are that users need to be able to filter room types in different hotels, then I'm going to go in and design my items in this table based on that access pattern. So there's tons of different ways of modeling your data in DynamoDB, but you always want to model it in the way that it's going to be accessed. The data will be accessed. So if my users are going to be filtering for rooms within a given hotel, I'm going to model that data based on these filters. So I can show a demo. Do you want me to share my screen and start with that demo?
What were you comfortable with? Yes.
Yeah, of course. So
I was waiting for that.
Yeah, I know.
Yeah, because something from the future will come in.
And Uriel, most of the time I use DynamoDB. That's infra guy. Most of the time to keep the state lock of the Terraform. So
Yeah.
I'm going to learn something new today.
Yeah, definitely. So I think you can see my right now I'm in the AWS console, DynamoDB console. So I have just one example. So for example, I have a hotel. I can have many hotels right in this table, but right now I have just one hotel which has the ID of 101. And there's different rooms. So I have 5 rooms. I actually just ran a scan, to show all the items in this table. So I have 5 items. These are 5 rooms. So as you can see by entity type here, they're all room items in this hotel. So now, since I know that the primary access patterns that users will need to do on this application will be to filter by room, I'm going to be modeling my primary keys like this. So PK is the partition key, SK is the sort key. So the partition key is the ID of the hotel, prefixed with the string hotel. So I have to get the ID of the hotel, and then I can just pass in PK as hotel, and then the ID. And then for the sort key, SK, I'm gonna prefix it by room so that I know it's a room. And then after that, if you notice here, I have hash floor, the floor number, then hash the type of room. So this one's a garden view. I have sea view, and then hash again, and I have the number of guests that that the room can accommodate, and then followed by the last thing is the ID of the room. So the actual ID is 205. Now, how would I actually filter this? So let's take a look at filtering this data here. So I can run a query here and say, use the partition key here, and since I want all the rooms in my hotel, in this hotel, which is hotel 101, I can set the partition key as hotel hash 101. That's the ID, and the sort key I'm going to select begins with, and you can do this obviously with the DynamoDB API, but we're doing it in the console to make it simpler, more visual. I can use the begins with API method, and over here, what I want to do is there's many types of filtering. Let's say I want to get all of the rooms without any filtering. Well, I can just pass in room hash and run that query, and I'm going to get all 5 rooms, because all 5 rooms are in that hotel. Now, I can get more fine-grained and filter by the floor that it's on. Okay, so if someone wants to be on a different floor, you can add in to the string, the sort key, floor 1, let's say, and that'll get 4 items because I had 1 item that was on the floor 2, I think. Then I can get even more filter, more deeper into that filter, and say, okay, get me all of the C views, for example. So that'll omit this one. So if I type in C view and hash and I run it, I get 3. So those are only the C views. So now I'm getting more and more specific into my filtering. I can say get me all of the rooms that have 3 guests, that accommodate 3 guests. So I can go in and type in 3 guests. Is it with an S? Yeah. And run, and that's going to get 2. And then I can also get specific and get the actual room by passing the ID. So then I just do 202, and that gets me the actual room. So you see, I'm doing a more and more fine-grained filtering based on the options that you provide in your application. So you can say, you can have like those booking.com apps where you can select the floor number, maybe just the view, so sea view, garden view, number of guests, is it smoking type or not smoking, all those types, you can add them, and based on the application and what filters you provide, you add those filters inside that sort key string right here. So if I wanted to add an access pattern for, let's say, to filter with smoking or non-smoking, well, I can just add it in here after whichever one you want. After 3 guests, I can just add in hash smoking hash 202 or hash non-smoking hash 202, and from there I can get into the query and in the sort key and filter for that smoking type of room. So that's more and more fine-grained filtering with sort keys.
Got it. Yeah, I mean, you're actually building this based on the access patterns and the different filters that are there. So sort key holds these values, and the way how it querying works, I mean, you can see that read capacity units consumed also that's being displayed, right? It's 0.5, but
exactly
when you do a regular query, it's much more, right? So yeah.
So I don't think it's gonna be more. If I'm correct, it's still gonna be the same if I do run. Yeah, it's 2. Okay, and I'll tell you why. So the a RCU uses up 4 kilobytes, or with eventual consistency, it's going to use up to half of that, which is 2. That's why we're getting 2. Now, if my data if I'm doing less, like when I had the query here, I think I had much less than 2 kilobytes. So that's why I had 0.5. But it's not going to make much of a difference here. But actually, you could see it, because since we saw the hotel, I think we saw 0.5, and now we have 2 because there's much more items. But this gets more important when you have a lot more items, because when you're sorting, when you're using the sorting, like I showed with the sort key, you can have like we saw 0.5. But whereas if I'm using a filter expression like we saw before, well, like for example, if I do a scan here, then
scan with some filters.
Yeah, with or without filters, it's not going to make a difference, because filter expressions are only being applied after the fact. So this is how it works. When you're using a filter expressions, and this is why you shouldn't use a filter expressions. Filter expressions, what they do is they first fetch all of the data in that partition, and then once the data is returned, then then DynamoDB is applying the filter after the fact. So you're using up the same amount of capacity units, whether you filter it or not, right? Whereas in the sort key filtering that I just showed earlier, well, we saw that the read capacity units were at 0.5, because it's a real filter. It's actually filtering the data that you asked for, and nothing more. Whereas, and I can show you, we can look at it, another example here. If I do entity type, let's say, or no, let's do a room ID here.
Yeah.
Room ID. So we'll do the same filter that we did the sort key filtering, but we're going to use FilterExpressions to show the difference. So if I want to get all items where room ID contains, what is this? Yeah, it's a string. Okay, contains the value, for example, cview. So you see the units consumed were still 2. So no matter what I put in here, the units will still be the same. If I put, like, let's say 2 guests, which I think there's just 1. See, it's always 2. No matter what I'm going to put, the read capacity units are still going to be 2, because it's like I said, you're fetching all of the data and then applying the filtering after. Whereas back when we were here with the sort key filtering, if I pass in hash 1 and if I do begins with, for example, I pass in a cview hash. And I remove this. You see, I did the same type of filtering, but now I'm using only 0.5 capacity units. So you can actually see that it's using a lot less capacity units, and that means less cost and a lower latency for your queries. So, and imagine this one at scale. If you have thousands of items, if you're only filtering, a few out of 1,000 or 1,000,000, it can get really, really dramatically more efficient to use sort key filtering. This is the exact reason why you don't want to use FilterExpressions.
Got it. Yeah, I think it's also about the internals of DynamoDB and how it works, right? Because when it's querying, it's using the table's definition, be it the partition and the sort key. But when scanning, it's taking everything from the partition and then applying the filters on top of it. So it's much more. It's less performant.
Exactly. Yeah. That's it.
Yeah, literally my page is like that because.
Awesome. So, in terms of what are the other capabilities with respect to the sort key and the ways of you could query it, right? Begins is one, and the other is, if I'm not wrong, it's between, right? So,
yeah, so
you want to touch upon that?
Yeah, for sure. So with DynamoDB, there's 2 different types of operations you can do on your data. So your data is like I mentioned earlier. There's 2 types of data on an item. There's the primary keys, which are similar to SQL, I would say, but not too similar. And those are schema enforced. So that means that you can only your primary keys, which is your PK and SK here, partition key and sort key, they can only be of the types number, string, or binary. You can't have an array or an object map or any of that other data types. Whereas any other item that you can create, so I can create other items, you see like entity type or room ID, those are non-primary keys. Those, they can be any type. I can put arrays and maps. Now, when I want to query a primary key, I can only perform the following operations. I can do greater or equals to, equals, of course, smaller or greater, so equality operators, and then I can do begins with, like we see here, begins with, and then I can do between. So between, so begins, we just saw what it does. Between, so you can see them here, equality, and then between and begins with. Between would be useful for range queries. So for example, let's say I had an access pattern where, let's say the administrator of this database would need to query all of the rooms between floors 1 and 3. So what they can do is they can run a betweens query here and do between floor 1 and floor 2. I guess we just have 2 floors, so that'll return all of them, all of the items. Okay, can do. Yeah, can do. I think it's hash. No, it's not hash. It's in that case we could do floor 3, and that would exclude the floor 3, and then that would just get all of the items. So we have floor 1 and floor 2. So we're not getting anything floor 3 because it's in your between query. You're saying up to this, and we don't have any item that is that has a sort key of floor 3, because they would all have floor 3 hash, something else like cview, etc. So by specifying floor 3, you're only getting rooms from floor 1 to 2. This works also well with dates. I can say get me all items that have the date 2025 February 1st till March 1st, right? And then that'll get me all items that are within that date. So between queries, between is very good for a range, date range, or any type of string or number range queries. So those are, equality between begins with. Those are the 3 types of query operations you can do with primary keys. And then for anything that's not primary key, like any other keys here, like entity type, room ID, which is basically every other attribute, you can do actually all sorts of filtering or operations. You have them all here: equal to, not equal to, less than or equal, the equality operators, of course, between, like with primary keys, exist, not exist, contains and not contains, and begins with. And it's the same thing as like we saw before. It's anything that you do here, any operation that you do here is going to do it after the fact. So first your data is going to be fetched, and then that condition is applied. So you're not really saving any RCUs or money. You're not saving any latency or money. But you're getting the data with that with that operation. So those are the two types of data types and their operations that you can do with DynamoDB.
Awesome. So if I have to talk about the GSIs that is supported on DynamoDB, can we also do the similar filters with the sort key there?
Yes. So a GSI is really a mirror image, a replica of your base table. That is kind of, sometimes we call it a sparse index, because how GSIs work is that they only record the values that have the primary keys of the GSI. What does this mean? Well, when you create a GSI, like here, I'm going to show you an example here. If I want to go in and, no, not global table. It's on create a GSI. Where's the export table item? No. Index is here.
Yeah.
If I want to create an index here, I have to supply a new partition and sort key. So my base table partition key and sort key is PK/SK. So if I want, I can create a new one called GSI PK and GSI. See, I've done it already. GSI PK and GSI SK. And when I create this, now any item in my base table that have these keys will be added to the GSI, and any item in my base table that don't have these keys will not be added. So if I show you an example, if I go into my table items, over here I have room ID, entity type, PK and SK. Now, if I create a GSI with the primary keys, like I showed you, GSI 1 PK, GSI 1 SK, or any key, those are typical keys we give, but you can give any key name. Well, none of these items will be added in. My GSI is going to be empty because none of these items have GSI 1 PK or SK. But if I go in here and add it in, as soon as I do this, GSI 1 PK, and supply a value here, that item is going to be added to the GSI. Okay. Now, when it's added to the GSI, it works the same way as the base table. You can do the same exact operation. Nothing changes. So on my primary keys of my GSI, I can only do betweens, begins with, and equality. And so it's the same exact thing as the base table. Nothing changes.
Got it.
I think that answers the question.
Yeah, it did. Thanks for that, Uriel. Wow. It all boils down to your access patterns and how do you design with the data in mind, right?
Exactly. Yeah, because if you're imagine a case where you're with SQL, the problem I think is because with SQL we're not used to that. We're not trained to do that. In SQL you're trained to create one table per entity, and then add foreign keys and then join the tables together to fetch related data. But in DynamoDB, since we don't have joins, you don't have foreign keys, you don't have all that. Well, to most efficiently query your data, your related data, you need to pre-join them. So for example, it gets into another thing, but basically pre-joining means I can have my hotel, that's my partition key for that hotel. Well, I can, instead of having a room item here, I can add a new item, but make it for example, a guest, right? So that would be a guest item. And instead of room, it would be called guest, and I would have the guest ID. So here I'm pre-joining my data, because now I'm joining rooms with users or guests, right? So now I can query two different entities in the same partition. So now I can provide hotel #101 and then get all the rooms that are in this hotel, in my hotel, and all the guests that are in there. So you see, I'm pre-joining the data rather than than post-joining, like you would say in SQL. Because in SQL, it's nothing is joined, but then you use join operations after. Well, in DynamoDB, it's just the opposite. You're joining them in the partition. So you have, under the same partition, you have rooms and guests and whatever else, and then you're able to query those together. So it's like Rick Houlihan famously said that all data that is queried together has to be stored together. So this is what we're doing here. If we want to, commonly, if we have an access pattern where we want to fetch rooms and guests because it's related data, then we have to store it together. So that's why it all boils down, like you said, to access patterns. If my access patterns don't need to fetch rooms and guests, I can store them separately. But if they do need to, then to fetch them together, then I need to pre-join them together. So that's where it all comes down. I have my access patterns, I understand them, I know exactly how users will query the database, and then now I have to model my database design based on these access patterns. And I can't really do this after. It would be a lot more inefficient to do it after, because you're going to need to start adding GSIs and model your data every time you have new access patterns. It's better to just get all your access patterns first and then model your data. Then I did have this question once where someone said, but maybe 6 months down the line or a year down the line, you might have new access patterns that emerge, that you can't think of at first. Well, my answer is always the same. That's not a problem. It's never a problem. You do your best at you have an MVP. You do your best at identifying your access patterns. Once you get them all down, you model your data. But then if later you have more access patterns, that's not a problem. You can create another GSI, and then you can do key overloading on the GSI to enable multiple access patterns, so that you can have multiple access patterns on just one GSI instead of creating a GSI for each access pattern. So there's ways to do key overloading. It's a more I think it's really what we're doing here. That this is really key overloading. It's not that difficult of a concept. I was going to say it's a little complex, but it really isn't. This is really what key overloading is. Where I have my SK, and instead of adding just a room ID, hash ID, I have room floor 1, garden view, 3 guests. This is what is called key overloading. I have multiple different values in my sort key, and with that I can also have a guest. I can have a guest item, so I can have guest hash date, maybe the date he checked in, then ID or the room he's staying in. So I'm overloading my keys by having multiple different values in my sort key, rather than having just a user ID, room ID. I have multiple different values, and in there I also have I can enable different like filtering, like we saw earlier. So you can get very, very powerful by just understanding data modeling with DynamoDB, and you can do a lot of powerful stuff. Yeah.
Awesome. Yeah, great analogy.
Thank you.
Amazing. I think you touched upon the concept of single table design, right? Because DynamoDB, that's how it's designed, where you bring in all the data together and then you build your query patterns. So somebody who's coming in from the traditional SQL world, would you recommend them the single table design and following queue-based access pattern, something like this?
So I would say that you definitely want to learn the single table design, but not use it 100% of the time, if that makes sense. So it's very important, because I would say 80% of the time, or maybe even more, you do want to use a single table design, just because most of your data will be relational. You're saving on table cost, because you're in DynamoDB, you're paying per table. In provision mode, you're paying per RCU of your queries. So if you're querying data from multiple different tables, then if you're querying data from 5 tables, you're paying 5 times more than if you have just one table, obviously. So, well, not querying. Sorry, what am I saying? I mean, if you're provisioning. Sorry, if you're provisioning. Let me go back. If you're provisioning data, if you're provisioning throughput for each of your 5 tables, let's say you have 5 entities, right? Data entities. You have users. You have guests. You have hotels, etc. So you have 5 tables for those. If you're provisioning a throughput for each of those 5, you're paying 5 times more than if you have just a single table, obviously, right? Because with a single table, you're provisioning throughput for one table, so you're paying 5 times less. Now that's just with provision mode, but with on-demand mode, the costs don't have any effect, because with on-demand you're only paying for the pay-per-use. So if you have, whether you have 10 tables or 1 table, it's not going to make a difference. So that's also a criteria to evaluate. If you're always using on-demand, which is not always recommended, because it can, you have less control of your cost. You can also do a lot of, a lot with the provision mode, where you provision and auto scale it, right? So on demand is, it's useful, but it maybe not for every use case. So but on the case where you do have on demand, then you lose the advantage of price for one table, but you don't lose the advantage of latency. So, and that's like equally important, right? This is like the main motivation behind the single table design, is that if you have your data in multiple tables, and you want to fetch, for example, you have users. Let's say you have an e-commerce application. In an e-commerce application, you have users that are purchasing products. You have transactions, you have payments, you have orders, right? Now, imagine you want to query a transaction that a user made. You have to go in and fetch first the user, right? You pass in the user ID, you get the user, you get the order, and then with the order you get the transaction, because the transaction is only going to come from the order, and the order comes from the user, right? So here you're querying 3 tables, and they have to be done in sequence, because you need first the user data, then the order data, then the transaction data. You're querying 3 tables. Well, you're paying 3 times more, and your latency is 3 times slower, because you need to wait for each data to be returned. Well, with the single table design, you eliminate those costs and the latency, because you have your order item, your transaction item, and your user item all on one partition, and you're just querying that user partition, and you say, give me the order, the user, and his transaction, the items. Get those items. You're getting it in a single request, and you're using a single table, and you're paying a lot less for it, and you're getting it much faster. So it's like, you have all the reasons to use a single table. There are some cases where I wouldn't recommend a single table. Like, for example, if cost is your main motivation, and you're using on demand, you don't have a cost advantage, but I mean, you would still have a latency advantage. But if sometimes you might not want the single table design, because I haven't many times come across the use case of not needing the single table design, but I have come sometimes. I think, like, when the data is not really relational, like it has like nothing to do with one another, then you wouldn't use a single table design. So, for example, if you have maybe a chat app, and in the chat app you also have like maybe an e-commerce app, for example, that has chat, right? You can chat with support. Well, I don't know if it would make much sense to store your chat messages, chat conversation, everything in the same table as your e-commerce table. So in that case, you might want to go with multi-table approach, but in the e-commerce one, you still want to do single table design, right? So it all depends on your use case. Sometimes you don't want to mix non-related data together, but when the data is relational, of course, you want to use the single table design.
Got it. Yeah, I mean, when the data is related to each other, like in the hotel example itself, hotels at guests makes sense to have it in a single table. But like you called out, for an e-commerce site with support chat does not really make sense to have it in the same table, right?
Yeah.
So it's all about, again, understanding how your data is being distributed and designing according to the data.
Yeah.
So I
Exactly.
think the mantra there is design based on your data and the access patterns.
Yeah, that's that's my main takeaways. I've written a lot about it. I think that the main takeaway here is if you're if you're building with DynamoDB, the first one is always understand your access patterns, before you start designing. Then the second takeaway I would say is, you know, learn proper partition key and sort key design, because it's all of the power in DynamoDB is all in the partition key and the sort key. Partition key has to be high cardinality, meaning it has to be unique. So hotel hash 101, for example, is a very high cardinality key, because you're not going to have two of those. You can't have two hotels with the same ID. That enables scalability, because the more unique your primary keys, your partition keys are, the more it can scale. Well, the more you allow it to scale, but then you still have to model your sort key right and queries right, of course. But yeah, like I often say, with DynamoDB, you can't make a bad query. Well, it's not me who says it; it's more Alex DB, but I took it from him. It's a known thing. You can't design a bad query, because DynamoDB only lets you, which comes back to why you can only do those three types of operation. The equality, the begins with, and between, because those three operations, you're limited to those for the exact reason to not let you do a bad query. Because if DynamoDB would let you do the contains and all those other ones we saw, you would be able to design bad queries and have like a lot higher latency, and higher cost. But DynamoDB doesn't want you to do that. It's designed for scalability and super low latency, and because of that, they only give you operations like between and begins with, and equality operators to make your data fetching really fast. So it's all about learn the data design of primary keys, partition keys, sort keys, and use on-demand or provision mode with auto scaling. And there's no limit to how scalable you can make your data DynamoDB tables.
Wow. Yeah, that's an amazing insight, Uriel, in terms of understanding the access patterns, designing based on it, and also designing the partition and the sort key, right, for making it more efficient with respect to querying them, and be it with respect to the different kind of filters that you may have to add on top of your query, right? Having them in the sort key and then doing all the query operations makes it more efficient. So thank you, Uriel, for that wonderful insight.
It's my pleasure, Jones.
Yes, and thank you, because as more into infra and Kate's guy, and I was like, oh wow, and I learned a lot. I really love these RTUs like you explained. So I have learned these things, obviously when I was like doing for certifications, but those things like never tried out like in depth. But you motivated me to post for Kubernetes stuff for a while and just give a try today. So I took some notes to be honest, while you're explaining, right? I took some notes even to myself. Yeah, I'm gonna give a try, and yeah.
I hope you learned a lot.
A lot, man. A lot. I was like, I'm trying to digest.
Yeah, sure.
Awesome. Yeah, I think there's a question, not on DynamoDB, but on AWS per se. So Zach, you want to answer that? Zach or Uriel?
Yeah. Or we can give to Uriel first, or else I can go ahead. It's fine.
Yes, but I know so many people want to learn it. Is it a question? I don't know.
All right.
But
I think it's more of a comment.
Yeah, of course. Yeah, I'm sure it can come in useful when you want to build, scalable databases. Yeah, a lot of solutions out there. A lot of us use MySQL, but it's hard to scale. So I think that's where big motivation behind using DynamoDB is for scale, I think. Yeah.
Awesome. And I don't think we have any other question. So thank you, Uriel.
If anyone has any questions, they can ask me on LinkedIn. You can send me a message, or on my blog. I think you put the links below. So it'd be a pleasure to answer any questions there. Yeah, that's it.
So this is the blog link. So inside your blog, there are a way to contact you, right? Like your LinkedIn URL and everything. It's already there.
LinkedIn, LinkedIn, they can message me. I'm active on it. I'm there every day to answer the questions directly. You can book me for one-on-one call if you have. I do free 15-minute consultations, so they can book me on that if you have like longer questions to ask me. And if you want to read my blog for examples like we saw here, you can take a look at my blog on Medium and read and comment your questions there. Yeah.
So this link is for if anyone wants to book you for consultation. You mentioned like 30 minutes or 15 minutes free?
I'm sorry?
You mentioned some time, right? Like it's going to be 15 or 30 minutes free.
Yeah, I offer 15-minute, for free consultations. If you need longer, I can always accommodate a bit longer, but yeah, definitely.
Okay, cool. You might see my booking first then.
With pleasure.
Awesome. Yeah, and of course, I've read your blog, so it has a ton of information around DynamoDB and the access patterns. And what we spoke today is just the speck of the eye.
The iceberg, exactly. Yeah. Thanks a lot. It was really a pleasure. Yeah.
Yes, and I appreciate, like we are crossing 3 time zones.
Yeah.
Yeah, I'm from the future still. You're from the past.
Yeah.
Awesome.
No, thank you so much, Uriel, again.
Thank you, guys. Thank you. Yeah, it was really a pleasure speaking DynamoDB with you guys, and I really enjoyed it.
Yeah, hope we can have you in another episode soon.
Yeah. We can talk about the controversial topic of single table design and multi-table design, maybe. So,
I think a very interesting topic because it's pretty big for next episode to be the single table design. There's so much, value in there, and there's a lot to speak about. And I think users, audiences can get like a lot of value from learning the single table design. So that can make for a very interesting talk in the future.
Awesome. Yeah. Awesome. So thanks, Uriel. You've certainly got a lot of fans who have really loved the way how you have explained about filtering and the access patterns with respect to DynamoDB. So
awesome.
Thank you.
Thanks, Zach. Yeah.
Yeah. And until next time.
Until next time, enjoy your future, Zach.
Yes.
Signing off until next time. So thank you all. Bye.
Bye.